Hello students, welcome back to your favorite YouTube channel, Tomachang Tutorial. Myself Kishan Kulum, and today we are going to discuss about graphical representation of Charles' law. We have already done Charles' law in our previous video. If you would like to check out that video, you can click the link below in the description and watch that video again. Okay? We have seen that Vt equal to V naught 1 plus T upon 273. This is the equation of Charles' law. We have already proved it in the previous video. Now let us begin with the graphical representation of Charles' law. But before that, let me again remind you the constants of Charles' law. Constants of Charles' law. What are the constants of Charles' law? Pressure of the gas and mass of the gas. Okay? Pressure of the gas and mass of the gas are kept constant in Charles' law. Please remember, in Charles' law, pressure is kept constant and mass is also kept constant. Mass of the gas is also kept constant. You must remember this, so please remember this. Okay, now let us begin with the graphical representation of Charles' law. This is y-axis, okay, and this is x-axis. X dash, y dash, and this is the point of intersection. Here the values of x and y both are 0. As you know that when we move from left to the right hand side, the values of number increases in x-axis. Suppose this is 0, 1, 1 is greater than 0, and 2 is greater than 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, so on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on, continues, okay, up to infinity. And if you move to the left hand side, value decreases. -1, -2, -3, -4, and so on, okay. Similarly, if you move upward in y-axis, value increases. +1, +2, +3, +4, +5, and so on. And if you move downward, -1, -2, -3, -4, so on. Okay, if I plot temperature T in x-axis, that means if you move from left to the right hand side, temperature increases. Suppose at this point temperature is 0 degrees Celsius, 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius. If you continue moving towards right hand side, temperature, the value of temperature increases. But if you move towards left hand side, temperature decreases. 3 degrees Celsius, 2 degrees Celsius, 1 degree Celsius, temperature is decreasing. We are moving from right towards left. 0 degrees Celsius, -1 degree Celsius is lesser than 0, -2 degrees Celsius is lesser than -1, -3 degrees Celsius is lesser than -2, and -4 degrees Celsius is lesser than -3, and so on. If you move towards left hand side, temperature decreases, and if you move towards right hand side, temperature increases. Similarly, if I plot volume in y-axis, if you move upward, volume increases. Like for an example, just for an example, this is 1 liter, this is 2 liter, 3 liter, 4 liter, 5 liter. If you move downward, volume decreases. 5 liter, 4 liter, 3 liter, 2 liter, 1 liter, 0 liter, and so on. Okay. If you move upward, volume increases. If you move downward, volume decreases. I have plotted temperature in x-axis and volume in y-axis. So if I plot Charles' law in graph, how would the curve look like? Let me draw it for you. The curve may look like this. The curve actually looks like this, okay? Looks like this. Let me draw more accurately, straight line. Okay, the curve will look like this. So at 0 degrees Celsius, see, at 0 degrees Celsius, volume was this much. from here to here, because this is the line of volume, isn't it? So at 0 degrees Celsius, volume was this much, from here to here, this much. Let us say volume was V naught. At 4 degrees Celsius, if you increase the temperature to 4 degrees Celsius, V4, volume became little larger. At 7 degrees Celsius, volume became more larger, isn't it? So V7 is larger than V4. On increasing the temperature to 11 degrees Celsius, volume even became larger than V7. So from this graph, we saw when you increase the temperature, volume also increases at the same time. When you increase the temperature from 0 degrees Celsius to upward, 1, 2, 3, 4, 5, 6, 7, when you keep on increasing the temperature, volume also increases simultaneously. At 4 degrees Celsius, this much was the volume. At 7 degrees Celsius, this much is the volume. At 11 degrees Celsius, the volume is even larger. And even at higher temperature, volume will be larger, definitely, we know that. Now, we saw that the volume of gas at 0 degrees Celsius is this much, isn't it? So this is V naught. If we decrease the temperature below 0 degrees Celsius, what happens? Let's see. Suppose if I decrease the temperature, continue decreasing the temperature, this curve will meet somewhere here. Okay, and this point, where does this line meet is at minus 273. At minus 273 degrees Celsius. Minus 1, minus 2, minus 3, minus 4, dot, dot, dot. There are many numbers. Minus 5, minus 6, minus 7, minus 8, minus 10, minus 11, minus 12. And finally comes minus 273 degrees Celsius. This line meets x-axis at minus 273 degrees Celsius. What does this mean? At minus 273 degrees Celsius, volume of gas becomes 0. This graph proves that at minus 273 degrees Celsius, volume of any gas becomes 0. But when we studied Boyle's law, I have told you that volume and pressure of gas can never be 0. So how is this possible? Charles' law shows us that volume of gas can become 0 at minus 273 degrees Celsius. Actually, this is just a theoretical concept. The volume of gas doesn't become 0. Actually, what happens is, gas either liquefy or solidify. Okay. This minus 273 degrees Celsius is the lowest possible temperature that can be attained, and at this temperature, when temperature is minus 273 degrees Celsius, gas converts itself into either liquid or solid. Gas becomes either liquid or solid. Gas either liquefy or solidify. Okay? And you know that volume of solid and liquid when compared to the volume of gas is negligible. Volume of solid and liquid when compared to the volume of gas is negligible. So we can say volume of gas becomes 0 at minus 273 degrees Celsius. But the volume of gas is not exactly 0. Gas is either liquefied or solidified. Gas either liquefy or solidify at minus 273 degrees Celsius. This is what this graph tells us, and this is the graphical representation of Charles' law. I hope you understood, and if there is any problem or any doubt, you can comment in the comment section and I will explain in a better way. Thank you so much for watching my channel, and please don't forget to subscribe and hit the bell icon for more videos like this. Thank you.